today we are going to start the numerical problem on the scattering matrix. So, first problem is find the S parameters of the 3 dB attenuator circuit shown in below figure. So, here you can see that here are this is a 2 port network, port 1 is this side and port 2 is this side, and these are the resistance 8.56, 8.56 and 141.8 ohm. So, for this problem you have to find out the S parameters. So, we can do the solution, you can stop the video and do the solution. So, I can start the solution. So, for the S parameter means for the 2 port network. So, we know, so for the 2 port network, suppose it is like so this is port 1, port 1, port 2. So, first, so these are means we can define for the port 1 like this, this is V1 plus and V1 minus. So, signal for this will be like this. So, V1 plus that is the incoming and V1 minus is that is outgoing. Similarly, for port 2, this side at port 2, this side at port 2 will be V2 plus and reflected wave from port 2 we can denote like V2 minus. So, for the S parameter, suppose this is the for this network means S parameter, it can be defined as V1 minus, V2 minus and this will be in the matrix format equal to. So, these are for this 2 port network, this will be the S parameter network S11, S12, S21, S22 into V1 plus, V2 plus. So, this is in the matrix format and here this is the S parameter, that is 2 cross 2 and here it is 2 cross 1 and 2 cross 1. So, from this means from this matrix equation we can write V1 minus equal to S11 V1 plus S12 into V2 plus and V2 minus equal to S21 V1 plus S22 V2 plus. So, like this we can write V1 minus equal to S11 into V1 plus S12 into V2 plus and V2 minus equal to S21 V1 plus S22 into V2 plus. So, V1 minus that is the reflected from V1 1 minus, that is reflected wave from the port 1 and V2 minus reflected wave from port 2 and V1 plus that is the incoming wave from at port 1 and V2 plus that is incoming wave at port 2. So, to find out the S11 we from these two equation, to find out the S11 we can write S11 equal to V1 minus divided with V1 plus when V2 plus equal to 0. So, we are finding the S parameter of the question. So, first have to write means how we can define the S11. So, S11 can be written as from equation 1 S11 equal to S11 equal to V1 minus divided with V1 plus when V2 plus equal to 0. So, S11 can be defined as V1 minus divided with V1 plus when V2 plus equal to 0. So, V2 plus equal to 0, that means we can see V2 plus equal to 0, that means there are no incoming wave at port 2. So, how this can be possible? How this is possible? So, if this port 2 will be terminated with some, so because this V2 plus is like it is going through the port 2 here, V2 plus, and V2 minus is like this, V2 minus it is like this. So, when we will terminate the V means port 2 with match load, we can measure the S parameter in vector network analyzer. There means input impedance is of 50 ohm. For that 50 ohm means so that can be means to make the V2 plus equal to 0, port 2 can be terminated with match load. By this condition we can find out the S11. So, we can terminate the port 2 with match load of 50 ohm. So, this we can call as ZL. ZL at port 2 means we are matching the port 2 with match impedance. So, that here means there will be no reflected wave, means because it is match. So, there will be no reflected wave will come from the from this load, that means V2 plus equal to 0. So, like this we can define the V2 plus, since this is means and gamma means S11 we can also called as gamma. So, we can define the gamma for means when V2 plus equal to 0, gamma can be defined as, we can write gamma as means we can write gamma at port 1 means S11 we are finding out the S11 at port 1, that means it is same as reflection at port 1. So, reflection at port 1, that means it is same as gamma at port 1. So, it can be defined as Z in 1 at port 1 means at this port we are seeing the means Z in from here, Z in 1 minus Z naught divided with, here means we are measuring the this S parameter from the vector network analyzer that has the impedance 50 ohm. So, we have to assume that this side is also 50 ohm. So, Z in minus Z naught divided with Z in 1 plus Z naught, when means this port 2 is terminated with, because we are finding out this S11. So, port 2 is terminated with 50 ohm means Z naught. So, for this we have to find out the Z in 1. Now, we can come to the problem. So, our problem is now to find out the S11 we have to terminate the port 2 with 50 ohm. So, we have to this port 2 will be connected through the 50 ohm. So, that now that circuit will be like this. So, this will be 8.56. Now, first we have to find out the this means Z in 1, this will be 141.8, this is ohm, and after this is also 8.56. And because we are finding out the S11 and this is terminated with match load of impedance, load impedance 50 ohm, and we are seeing here it is port 2 here it is port 2 and we are seeing means input from port 1, this is port 1 and here it is port 2. We are seeing the input means Z in 1 from port 1. So, Z in we can calculate from this circuit. So, Z in will be 8.56 into this will be in the parallel 50 plus 8.56 into 141.8 divided with 141.8 plus this, and we can write like this. So, Z in can be written as 8.56 plus, now this side is in the parallel and 8.56 and this will be in the series with this 8.56 and these two are in the parallel. So, we can write 141.8 into 8.56 plus 50, no, it will be 50. So, it will be, so it will be 50 divided with 141.8 plus 8.56 plus 50. So, after calculating this means computing this, it will come 50 ohm. So, Z in 1 means input impedance at port 1, it is 50 ohm and S11 that is gamma in, that is gamma 1, that is defined as Z in 1 minus Z naught divided with Z in 1 plus Z naught. So, it is 50 ohm and Z naught is also 50 ohm. So, we will get S11 equal to 0, S11 equal to 0. Now, we can see that this in the question this network is symmetrical. When we will see from port 1 or we can see from the port 2, we will see the same thing and it is like a symmetrical network. So, by the same process S22 will also come equal to 0, because this network is symmetrical, S22 will equal to 0. After this, we have to find out the remaining parameter, that is S12 and S21. So, again means S21 and S12 will be same, because this is symmetrical, and after this we can see that S21 can be defined as V2 minus divided with V1 plus when V2 plus equal to 0. So, we can write that. So, S21 can be defined as V2 minus divided with V1 plus when V2 plus equal to 0. V2 plus equal to 0 means again port 2 is terminated with match load and we know S11 equal to S22 equal to 0. So, using the voltage division, and we can see that means so S21 equal to means V2 minus is you can see the figures. So, V2 minus is, it is reflected wave from the port 2, that is outgoing, and V1 plus that is incoming from port 1. So, we can see the S21 is a, that is a transmitted wave from port 1 to port 2. So, now we have to find out V2 minus. So, V2 minus we can write as means and V1 plus, because it is already matched. So, V1 plus equal to V1 and V2 minus equal to V2, because this V2 plus equal to 0 and V1 minus will also equal to 0, because this is matched with the 50 ohm line at port 2. From this, because V1 plus will be V1 and V2 minus will be V2, then V2 minus can be written as, so we can use the voltage division rule, equal to V2 equal to V1, that is port 1 voltage, into, so we have already calculated that into that 41 plus 44. So, this calculation means 8.56. So, how much this is coming? 50 plus 8.56 we can calculate, means we have to find out the voltage in this region, means in this case. So, voltage at this point will be, so we have to know the equivalent resistance this side, means in this side. So, this will be 50 plus, so we can calculate, that is 50 plus 8.56. I am doing in the calculator, so you can also do. So, that will be 58.56 into 141.8 divided with 58.56 plus 141.8, that is coming 41.44. So, V2 is equal to V1 into, so using the voltage division rule, that is 41.44 divided with 41.44 plus 8.56 into, because we are finding out the voltage across, means at port 2, and that is terminated with 50 ohm. So, into 50 divided with 50 plus 8.56. So, this is the V2, because here it is this, we got the voltage at this point, across this terminal. So, this voltage will produce some voltage across 50 ohm. Now, we are again applying the voltage division rule, and we will get 50 divided with 50 plus 8.56, just multiplying with that coefficient. By this we will get 0.707 V1. So, because, so this is 0.707. So, we can write V1 is V1 plus and V2 is V2 minus. So, we can write S21 equal to S12, because this is symmetrical from both sides, equal to 0.707. So, 0.707, that means it is 1 by root 2. So, we can show that this is the transmitted wave from port 1 to port 2, and it is transmitting the, means this much of amplitude, and this is 3 dB attenuator, 3 dB it is attenuated, and input power will be, we can find out. So, input power will be like input power we can find out V1 plus whole square divided with 2 Z naught. So, that will be the input power, and output power will be So, this is the input power. So, this is input power, and similarly we can write the output power. Output power equal to V 2 minus whole square divided with 2 Z naught. So, V 2 minus will be S 2 1 into V 1 plus whole square divided with 2 Z naught. So, S 2 1 we know, means and this can be written as S 2 1 whole square divided with 2 Z naught into V 1 plus whole square equal to. So, this S 2 1 is 1 by root 2. So, this will be equal to V 1 plus whole square divided with 4 Z naught. So, this is the output power. So, which is a minus 3 dB of the input power. So, this is the we got the means solution S 11. Now, we can write means S 11 will be 0, means S parameter we can write, we can denote like this matrix. S parameter will be S 0, 0.707. So, this is the final S matrix coefficient 7070. So, this is a 2 cross 2 matrix. Now, we can go to the second problem. So, here is the second problem. So, a two-port network is known to have the following scattering matrix. So, these are the known scattering matrix that is measured from somewhere or has been done in the lab, from the VNA it has been measured. Determine if the network is reciprocal and lossless. If two port is terminated with match load, what is the return loss seen at port 1? If the two port is terminated with a short circuit, what is the return loss seen at port 1? So, in this case we have three questions. First is S parameter is given. After that we have to see that this network is reciprocal or not. That is first part. In the next part it is if the two port is terminated with match load. So, if port 2 is terminated with match load, means it is also two port problem. So, if port 2 is terminated with match load, then what is the return loss seen at port 1? So, we will find out the return loss from the S11. So, in this case first we have to find out the S11. After that we will get the return loss seen at port 1, and in the next part, in the third part, it is if port 2 is terminated with short circuit. If port 2 is short circuit, what is the return loss seen at port 1? So, we will do this solution to this problem. So, we can go to the notepad. So, first we can write the means we can go to the second problem. So, what was the S matrix? We can write that is so this here it is in the angle it is given 0.15, 0 degree, 0.85 minus 45 degree 0.85, 45 degree, 0.2, 0 degree. So, it is a two port, it is a for the two port network this S parameter is given. So, we can see that S11 is not equal to S22 and also S12 is not equal to S21 and this is not symmetric. So, the network is not reciprocal. We got the solution for the first part. So, this network is not reciprocal. Since S is not symmetric, the network is not reciprocal. So, this is the solution for the first part, and to be lossless means any two port this S parameter should be lossless. So, it should satisfy the unitary condition. So, for the to satisfy the unitary condition we have to go for this S11. To satisfy the unitary condition we have to go S11 whole square plus S21 whole square equal to, so S11 is what? S1 is 0.15 and we are taking mod. So, all angle will be, so 0.85 angle of 45 degree 0.85. So, it will be 0.15 whole square plus 0.85 whole square equal to 0.745. It is not equal to 1. So, this is not equal to 1. So, this is not a lossless network. So, after this next question is, so it is not a reciprocal because this is not symmetric. It is not a lossless because it is not satisfying the unitary condition. Now, next part is, if the two port is terminated with match load, what is the return loss seen at port 1? So, if port 2 is terminated with match load, so it is same as previous question. So, here it is two port network and port 2 is terminated with match load. So, match load we can take ZL means ZL, Z0 we can take, it is terminated with Z0, that is match load. So, by the definition we can know that, means we know that by the definition we know that S11 equal to, that is V1 minus divided with V1 plus, when V2 plus equal to 0. So, if we are terminating the port 2 with match load, that means there will be no reflected wave from port 2, that means V2 plus equal to 0. V2 plus equal to 0, there will be no reflected wave from the port 2 because this is match load. So, by seeing the that matrix we can know that S11 will be 0.15. So, this will be 0.15 and return loss we can find out the return loss. So, S11 is 0.15. So, gamma will be equal to, that is gamma is reflection coefficient from port 1, that will equal to S11 and this will equal to 0.15 and from this gamma we can find out the return loss. So, return loss we can find out. So, definition for the return loss is minus of 20 log of mod of gamma. So, gamma will substitute 0.15, So, this will give 16.5 dB. So, this is the return loss at port 1 when port 2 is terminated with match load. Next part is, if the 2 port is terminated with short circuit, what is the return loss seen at port 1. So, now in the next part, so we have already solved this second part. If 2 port is terminated with match load, so ZL, that port 2 is terminated with 50 ohm or some match load, then in that case V 2 plus will equal to 0 and gamma will equal to S11. Now, in the next part, port 2 is terminated with short circuit. For this case, we have to find out the return loss. Now, port 2 is terminated with short circuit. So, it is short circuit. It is short circuit. So, here we cannot write V 2 plus equal to 0, because this is the short circuit. So, we can write, for this case we can write V 2 plus equal to minus of V 2 minus, V 2 plus equal to minus of V 2 minus, because this is short circuit. So, it reflected wave will be out of phase by 180 degree, and from the definition we can write V 1 minus equal to S11 V 1 plus of S12 into V 2 plus, because V 2 plus equal to minus of V 2 minus. So, we can again write this V 1 minus equal to S11 V 1 plus minus of S12 V 2 minus. After this, for the second equation we can write V 2 minus equal to S21 V 1 plus of S22 V 2 plus. So, V 2 plus equal to minus of V 2 minus. So, this can be written as S21 V 1 plus minus of S22 V 2 minus. So, from this expression we can write, so after taking the common V 2 minus, we can write V 2 minus equal to S21 divided with 1 plus S22 into V 1 plus. So, we are taking common this V 2 minus. So, this will be S21 divided with 1 plus S22 into V 1 plus. So, this is the V 2 minus. Now, we are dividing this first equation, this V 1 minus equal to S11 V 1 plus minus S12 V 2 minus by V 1 plus. When we will divide this expression with V 1 plus, so this will equal to V 1 minus divided with V 1 plus equal to S11 minus S12 into V 2 minus divided with V 1 plus. So, we will get this, and V 2 minus divided with V 1 plus. From this part V2 minus divided with V1 plus will give S21 divided with 1 plus S22. So, we can write from here S11 minus S12, that is S21 divided with 1 plus S22. So, this is the V1 plus V1 minus divided with V1 plus. So, we can call, so now we have means this V1 minus divided with V1 plus, this is in the form of means in the S parameter. Now, we know this term is known as gamma, and we have calculated this parameters using ZL is equal to 0, that means short circuit. So, we can call gamma is equal to V1 minus divided with V1 plus equal to S11 minus S12 S21 divided with 1 plus S22. Now, all the values of the S11, S12, S21, S22 we can substitute from the matrix, it is given in the problem. So, this will be equal to 0.15 minus 0.85 minus 45 degree and multiply with 0.85 plus 45 degree divided with 1 plus S22, 1 plus 0.2. Phase is 0 degree, that means we can write 0.2. So, this will give, after calculation, this will give minus 0.452. So, this is the gamma, and then return loss can be find out by minus of 20 log of mod of gamma. So, that will mod of this negative sign will be positive inside the mod. So, that will equal to minus of 20 log of 0.452. So, this will equal to 6.9 dB. So, this is the return loss when port 2 is terminated with short circuit. So, this part is completed now. Thank you.